right, HL students. So I'm looking at the review already, getting these videos up a little ahead of time, and going through each of the exam style questions. So we've got two events, A and B are independent, and we know that their probabilities are zero point 0.3 and 0.8. So state with a reason whether the events A and B are mutually exclusive. Um, so a couple different ways you could approach this really. If you think about it like a Venn diagram, mutually exclusive means that circle A does not touch circle B. And if I think of that image, the first thing that comes to my head is then, well, if I want to know the probability of A happening or B happening, then I can just add P of A plus P of B. Remember, the formula in general has minus the intersection right here. And if I, and if they're mutually exclusive, then you know that the intersection is equal to 0. So that's one thought that I have here. Another thought that I have is that using the idea that the events are independent. When they're independent, that means that the probability of A given B is just equal to the probability of A because it's independent. It doesn't matter that we know probability that B already happened. Probability of A given B is the same as just probability of A. And so we can use then Bayes' theorem over here to say, okay, well, that means I know that the probability of A and B divided by the probability of B is equal to the probability of A. And so that would mean the probability of A and B is equal to the probability of A multiplied by the probability of B. And this is this is one definition of events being independent. And then this is an alternate definition. If you know your events are independent, then you can just multiply their two probabilities right there. And so in general here, what we can do is say that the events are not mutually exclusive. So let's look at it. If we do probability of A and B in our specific example, we have 0.3 multiplied by 0.8, and that means the probability of A intersect B is not 0. And so we know that they are not mutually exclusive, because mutually exclusive would mean, again, that the intersection is equal to 0. And so because they're independent, we can multiply the probabilities. We don't get an answer of 0, so they're not mutually exclusive. So I'll write it like this. P of A intersect B is greater than 0. Thus, A and B are not mutually exclusive. So it took me a little bit of rambling to get there, but the idea is mutually exclusive means they don't intersect. If they're independent, we know we can multiply their probabilities, and we don't get 0 as an answer. Therefore, they do intersect. Another way you could have approached it is just adding the probabilities of A and B, and noticing that if you add the probabilities of A and B, you get a number that's greater than 1. So let me show you that other idea here. If you see this right here, you get a probability that is greater than 1. And what that means is that this probability must be greater than 0, because we know that any probability has to be less than or equal to 1. And so the only way that you could get a probability that's less than or equal to 1, if you have a sum that's greater than 1, is if you're subtracting a positive number. And so that's another route to showing that they're not mutually exclusive. Okay, I have belabored the point enough. Find the probability of each of the following events. We already did probability of A intersect B is 0.24. We can use that to find A union B by saying it's A plus B minus the intersection that we just found. So let's see, that makes 1.1 minus 0.24. What does that make? 0.86, I believe. sounds right to me. Then A given B prime, A given that B did not happen, is just the probability of A because they're independent. So you know it's 0.3. And then A prime intersect B right there. Well, if A and B are independent, so are A prime and B. And so from there you can just go A prime happens 0.7 and B happens 0.8, and 7 times 8 makes 56. So 0.56 is the probability there. And that's it for problem 12. Let me know if you have any questions, comment, respond. I'll get back to you.